This channel has been established for visually impaired people. For the visually impaired people, voice narration and a written expression are also provided for the hearing impaired. Don't forget to subscribe to our channel. Transaction Processing Facility TPF is an IBM real-time operating system for mainframe computers descended from the IBM System 360 family, including zSeries and System Z9. TPF delivers fast, high-volume, high-throughput transaction processing, handling large, continuous loads of essentially simple transactions across large, geographically dispersed networks. The world's largest TPF-based systems are easily capable of processing tens of thousands of transactions per second. TPF is also designed for highly reliable, continuous 24/7 operation. It is not uncommon for TPF customers to have continuous online availability of a decade or more, even with system and software upgrades. This is due in part to the multi-mainframe operating capability and environment. While there are other industrial-strength transaction processing systems, notably IBM's own CICS and IMS, TPF's specialty is extreme volume, large numbers of concurrent users, and very fast response times. For example, Visa credit card transaction processing during the peak holiday shopping season. The TPF passenger reservation application PARS, or its international version IPARS, is used by many airlines. One of TPF's major optional components is a high-performance, specialized database facility called TPF Database Facility TPF-DF. A close cousin of TPF, the Transaction Monitor ALCS, was developed by IBM to integrate TPF services into the more common mainframe operating system MVS, now z/OS. Contents: 1 History, 2 Users, 3 Operating Environment, 31 Tightly coupled, 32 Loosely coupled, 321 Processor Shared Records, 322 Processor Unique Records, 4 TPF Attributes, 41 What TPF is not, 42 What TPF is, 421 Data Records, 422 Programs and Residency, 423 Core Usage, 5 References, 6 External links. History. TPF evolved from the Airlines Control Program ACP, a free package developed in the mid-1960s by IBM in association with major North American and European airlines. In 1979, IBM introduced TPF as a replacement for ACP. Travelport Galileo, Apollo, WorldSpan, Access Japan GDS, Citibank, Citifinancial, Air Canada, Trenitalia Reservations, Delta Air Lines Reservations and the NYPD 911 system. Japan Airlines has publicly acknowledged they are running TPF operating environment. Tightly coupled TPF is capable of running on a multiprocessor, that is, on mainframe systems in which there is more than one CPU within the community. The CPUs are referred to as instruction streams or simply I-streams on a mainframe or in a logical partition LPAR of a mainframe with more than one I-stream. TPF is said to be running tightly coupled due to the reentrant nature of TPF programs and the control program. This is made possible as no active piece of work modifies any program. The default is to run on the main I-stream, which is given as the lowest numbered I-stream found during IPL. However, users and/or programs can initiate work on other I-streams via internal mechanisms in the API which let the caller dictate which I-stream to initiate the work on. In the new TPF, the system itself will try to load balance by routing any application that does not request a preference or affinity to I-streams with less work than others. In the TPF architecture, each I-stream shares common core, except for a 4 kilobits in size prefix area for each I-stream. In other instances where core data must or should be kept separate, the application designer typically carves up reserved storage areas into a number of sections equal to the number of I-streams. A good example of the TPF system doing this can be found with TPF's support of I-stream unique globals. Proper access to these carved sections of core are made by taking the base address of the area, and adding to it the product of the I-stream relative number times the size of each area. Loosely coupled TPF is capable of supporting multiple mainframes of any size themselves. Table. However, when the lock is obtained offboard of the TPF processor in the DASD control unit, an external process must be used. Historically, the record locking was accomplished in the DASD control unit via an RPQ known as LLF Limited Locking Facility, and later ELLF Extended. LLF and ELLF were both replaced by the Multipathing Lock Facility MPLF. To run clustered loosely coupled TPF requires either MPLF in all disk control units or an alternative locking device called a coupling facility processor. Shared records. Records that absolutely must be managed by a record locking process are those which are processor shared in TPF. Most record accesses are done by using record type and ordinal. So if you had defined a record type in the TPF system of Fred and gave it 100 records or ordinals, then in a processor shared scheme, record type Fred ordinal 5 would resolve to exactly the same file address on DASD. User on any two or more processors examines the file address that record type Fred ordinal 5 resolves to. They will note a different physical address is used. TPF attributes. What TPF is not. TPF has no built-in graphical user interface. GUI. TPF's built-in user interface is line-driven with simple text screens that scroll upwards. There are no mice, windows, or icons on a TPF prime. CRAS computer room agent set, the name given to devices which have been assigned to control the operation of the TPF system. All work is accomplished via the use of typed 1 or 2 line commands, similar to early versions of Unix before X. There are several products available that connect to the prime CRAS and provide graphical interface functions to the TPF operator. For example, the TPF operations server graphical interfaces for end users are typically provided through PC-based functions. TPF also does not include a compiler, assembler, text editor, or the concept of a desktop. TPF application source code is typically kept in PDSs on a z/OS system. However, some previous installations of TPF kept source code in z/VM-based files and used the CMS update facility to handle versioning. Currently, the z/OS compiler assembler is used to build TPF code into object modules, producing load files that the TPF online system can accept. Starting with TPF 11, Linux will be the build platform. Using TPF requires an intimate knowledge of the operations guide, since there is no ship support for any type of online command directory that you might find on other platforms. Commands created by IBM and shipped by IBM for the running and administration of TPF are referred to as Z messages, as they are all prefixed with the letter Z. Other letters are reserved so that customers may write their own commands. TPF has extremely limited capability to debug itself. Typically, third-party software packages such as IBM's TPF Toolkit, Step-by-Step Trace from Bedford Associates or CMS TPF, TPF, GI, ZTPF GI from TPF Software Inc. are employed to aid in the tracing and tracking of errant TPF code. Since TPF can run as a second-level guest under IBM's Z/VM, a user can employ the VM trace facility to closely follow the execution of code. TPF will allow certain types of function traces to operate and dump their data to a tape, typically through user exits that present parameters to a called function or perhaps the contents of a block of storage. There are some other types of trace information that TPF can collect in core while running, and this information gets dumped whenever the system encounters a severe error. What TPF is highly optimized to permit messages from the supported network to either be switched out to another location, routed to an application-specific set of programs, or to permit extremely efficient accesses to database records. Data records. Historically, all data on the TPF system had to fit in fixed record and core block sizes of 381, 1055 and 4 KB. This was due in part to the physical record sizes of blocks located on DASD. Much overhead was saved by freeing up any part of the operating system from breaking large data entities into smaller ones during file operations, and reassembling same during read operations. Since IBM hardware does I/O via the use of channels and channel programs, TPF would generate very small and efficient channel programs to do its I/O. Consisted of a single record aka segment. Therefore, a comprehensive application needed many segments. With the advent of C support, application programs were no longer limited to 4K sizes. Much larger C programs could be created, loaded to the TPF system as multiple 4K records and read into memory during a fetch operation and correctly reassembled. Since core memory was at a premium in the past, only highly used programs ran 100% of the time as core resident, most ran as file resident given the limitations of older hardware, and even today's relative limitations. A fetch of a program, be it a single 4K record or many, is expensive since core memory is monetarily cheap and physically much larger. Greater numbers of programs could be allocated to reside in core. With the advent of TPF, all programs will reside in core. into core and logical flow through the program is accomplished via simple branch instructions, instead of a dozen or so IBM instructions previously needed to perform what is known as core resident enter, back core usage historically and in step with the previous core blocks. References IBM Corporation TPF Database Facility TPF-DF Z, Transaction Processing Facility retrieved November 11, 2016. TP-FR's single largest online community of TPF programmers PCs training independent training company specializing in TPF TPF were COM job boards specializing in TPF and ALCS TPF SOFTWARE provides products. TOS, 360 TSS, 360 DOS, 360 and successors OS, 360 and successors OS, 390Z, OSVM Line ACP TPF IBM IXZ Linux DPCX DPPX SSP Point of Sale 4680 OS 4690 OS projects. Taligent Workplace OS Project Monterey Project Trillion K42VE Real-Time Operating Systems RTOS Comparison of Real-Time Operating Systems 4680 OS 4690 OS Bertos Chibios, RT Contiki DEOS Dianios DNIX DSOS Ecos Erica Enterprise Eros Flexos Freertos Funkos Hartos Integrity Junos OS Calibrios Linxos Menuetos MQX MERT, Unix RT Nano RK Nucleus RTOS NUTTX OpenCommertos OS 2000 OS 9 OS PKOS PSOS Prex QNX Real, 32 Rex OS Riot RMX RSX 11 RT 11 RTAI RTEMS RT Linux RT Thread Screenos